Okay, let's look at some examples of cross multiplying, and then specifically when you have to distribute. So first, notice this is a proportion. There's two ratios equal to each other, so we can cross multiply. And so if you multiply 4 times 30 and then 24 times w, that gives you a left side of the equation and a right side of the equation. So this is 24w is equal to 4 times 30. I'm not sure if I said that right earlier. 4 times 30 is 120. And then you need to divide by 24 on both sides to get w by itself. So then you just solve like normal. And I believe it's 5. So w is equal to 5. And then remember, you can check your work by looking back at the original problem. So 4 over 5, is that the same as 24 over 30? Well, if I do 4 times 6, I get 24. And 5 times 6 is 30. So I'm multiplying by that same thing, so that's fine. You can also think about reducing this fraction. This would reduce to 4 over 5 if you divided the top and bottom by 6. So look for patterns. Also, you can just look quickly to see if it even makes sense. Over here, the bigger number's on bottom, so w has to be bigger than 4. Okay, B and C bring up a common error that people make, and I would start by putting parentheses around any time you have more than one term in a fraction somewhere. So put parentheses around this, and this might help you remember that when you multiply, you're multiplying everything by 3. So 2 times x is 2x when you multiply across this way, and then cross multiply down here to get the other side of the equation, and it's 3 times x minus 6. Now you might be able to skip this step in your work as you get good at this, because maybe you can go ahead and distribute as you go. So this is 2x is equal to, and then distribute the 3, 3x minus 18. And then now we're just solving the equation. You could add the 18 and then subtract the 2 over. I think because I can get the x's by itself, I'm going to just subtract 3x from both sides. And so I'll have a negative x, which sometimes we try to avoid. But in this case, we'll just keep it here. And then when you divide by -1, it's going to change the sign. So we want to get x by itself divided by -1, or multiply by -1 if you want to think about it that way. And x is equal to 18. Now this one's a little harder to check your work because it's just a more difficult problem. It's more complicated. But you could plug 18 in for x and you get 3 over 18. So the bigger number's on bottom. And then this would give you 2 over 12. And so the bigger number's on bottom here. Another way to compare these and look for patterns. So 3 over 18 is 2 over 12. You can look at this and say, okay, all the same patterns we use, smaller number on top, smaller numbers on top here. But also you can look left and right. Like if 2 is smaller than 3, so this number should be smaller than 18. And you can reduce those to see that they both reduce to 1/6. So look for patterns as you are cross multiplying. Okay, pause the video and try C if you haven't already. And then let's see how you did. I would do parentheses around that, just so you remember that it's 5 times m minus 6 when you cross multiply, and then is equal to 4m. And then when you distribute, you get 5m minus 30. And then once again, I'm going to keep the negative 30 over here rather than move it and make it negative m. And I'll write that step in by subtracting 5m from both sides. And then divide by -1. Or just change the sign. And you get m is equal to 30. Okay, there's a couple word problems here. Go ahead and try those, and then we'll go through them. So push pause, see if you can at least set up a proportion, and then go through it. So here Georgia is making her own potting soil, and for every 4 buckets of peat moss, 4 buckets of peat moss, she mixes 3 buckets of perlite. So we're comparing peat over per. So peat over perlite. So 4 over 3 compares the peat over the perlite. And then suppose she uses 10 buckets of peat moss. How many buckets of perlite should she use? So peat moss is on top, so that's 10. And we don't know X. So that ratio, as you're writing that proportion, think about what you're comparing. What goes on top, what goes on bottom. And then cross multiply. Let's go ahead and write what X is. X is the buckets of perlite. And so cross multiply, and you get 30 is equal to 4x. And then x is, when you divide by 4 on both sides, you get 7.5. And so it's 7.5 buckets of perlite. And make sure your answer makes sense, right? Like we had a bigger number on top, bigger number on top. And then so 7.5 should be smaller than 10, which it is. You can also just look in context. So if I use 4 buckets of peat moss and then 3 buckets of perlite, I'm using more peat moss than perlite. And so if I use 10 buckets of peat moss, you think, well, that means I need to use more or less than 10 buckets of perlite. Okay, give that next one a shot really quick. So push pause. And then we'll try it together. So on a map, the distance between the Red River Gorge and Pine Bluff is 3.8 centimeters. If the map scale is 1 centimeter is equal to 25 kilometers, find the actual distance between the Red River Gorge and Pine Bluff. Okay, so this is one, there's a number of ways to approach this. We're going to use a proportion. And so this one's a little tricky because you got to think about what you're comparing. And the difference here is that our known comparison is given second. So we are comparing centimeters on the map compared to kilometers in real life. So kilometer is a way to measure distance. It's basically is a different way instead of miles. So the popular one around here is 5K. 5 kilometers is 3.1 miles. And so it's a way to measure longer distances. Okay, so centimeters on a map compared to kilometers in real life. Well, we know 1 centimeter on the map is 25 kilometers in real life. And then we know that the distance between the Red River Gorge and Pine Bluff River is 3.8 centimeters on the map. And if you want to use your units to help you, then that's okay. You can do that too. So 3.8 centimeters, and then we don't know how many kilometers it is in real life. So we will put X there for kilometers. But we've lined everything up. We figured out what we're comparing, centimeters and kilometers. We got centimeters on top, kilometers on bottom, and those could be switched as long as they'd flip over here, but centimeters and kilometers. You can also look left to right. So centimeters, centimeters, kilometers, kilometers. Everything looks good. So X is the distance between Red River Gorge and Pine River Bluff. And then cross multiply. So we get X, or 1X, is equal to 95 when you multiply those, 95 kilometers. And that's what we're looking for. And that's the distance. Once again, as I've said, I think on every single one of these, make sure your answer makes sense. So here, the bigger number was on bottom. So 95 is bigger than 3.8, which is good. And it's quite a bit bigger, like 1 and 25. Those aren't like necessarily close to each other. 3.8 and 95, that's quite a bit bigger. In fact, it's 25 times bigger. The other thing with this problem is you might see this. You might say, well, 1 centimeter is 25 kilometers. Well, you might know, well, if I have 3.8 centimeters, I'm just going to multiply that by 25. And that's okay. But make sure you can set up the proportion and solve with the ratio also, just because as the problems get more complex, and it might not even be this class, it might be Algebra 2, College Algebra, or the ACT even, it'll be useful to be able to set up a proportion. The nice thing about a proportion is you can set it up without really understanding the context. So if you had like no idea what was going on, but you could tell that they were comparing centimeters and kilometers, you could just set up centimeters over kilometers, and solve. And so a proportion is very, very useful when you have anything you're comparing in order to find something you don't know, some kind of unknown quantity. Okay, good luck with this and enjoy working with proportions.